Good morning, teacher. My name is Gaurav Banerjee.
Good morning, teachers. My name is Lokmanya Pradhan.
Today we will tell you about simple pendulum motion detection and as well as simulation of simple pendulum motion.
Pendulum is body suspended from a fixed point so that it can swing back and forth under the influence of gravity. The time interval of pendulum's complete back and forth movement is constant. It's 2 seconds.
Now we'll tell you of the objectives of this pendulum motion. First, measuring acceleration due to gravity. Second, experimental validation. Third, understanding simple harmonic motion. Fourth, analyzing forces on the pendulum mass.
Do you know in what ways does it help us?
The main point of this pendulum motion is the length of the string that is represented by L. Now we will tell you about the relationship between string length and pendulum period.
Predictive model. Establishing a predictive model to estimate the period based on the string length. This is very helpful in simple pendulum. Mathematical relationship. The period of pendulum is directly related to the square root of string of length. Direct proportionality. The pendulum's period increases as the square root of string length increases. This is the most important point in simple pendulum length of string.
Practical implications. Understanding this relationship aids in predicting pendulum motion variations accurately. Experimental observation. Experimental data confirm the direct proportionality between string length and pendulum period. Graph representation. Graphical depiction illustrating the correlation between string.
We will tell you about applications of simple pendulum. First, timekeeping. Historically used in clocks. Education. Used as an educational tool to teach concepts of periodic motion and mechanics. Third, gravity measurement. Measuring the period of a pendulum allows for the calculation of local gravity.
Structural analysis applied to analyze stability and oscillation behavior in structure like bridges and skyscrapers. Seismometers used for earthquake detection. Now I will tell you about some elements of this simple pendulum. First we use frictionless pivot. Then we use massless rod. Then we use massive bob. And now I will tell you about the how to calculate the time period. The formula is T equals to 2 pi under root L upon G.
Here, t is equal to time period, pi is equal to pi, L is equal to length of the string, g is equal to acceleration of the gravity.
How we made this pendulum? We had made this pendulum by the website Tinkercad. As you can see, we had used this rod and this bob, and we gave this animation by this pivot.
We have used pivot connector to give the animation and also a slider connector.
This is our complete simulation.
As you can see, here is the simple pendulum motion. When it detects a motion, it moves. A 3D pendulum is a rigid body supported by fixed frictionless pivot acted on by gravitational forces. The supporting pivot allows 3 degrees of rotational freedom of the pendulum. Uniform constant is gravity assumed. Here is the simulation of 3D pendulum.
This is our complete project on simple pendulum motion.
In this project, we have shown 3D simulation and also a PPT on simple pendulum motion detection. This is made by me, Lokmanya Pradhan, and Gaurav Banerjee. We both are of class 9.
Bharati Public School NTPC Sipat. Thank you.
Thank you.